Number 20, sorry, no, sorry, number 17. At A, at constant pressure, how does temperature relate to the volume of a given quantity of gas? Now, while we're reading this question, let's make sure we understand all of the information that's being given to us by the question. We do not want to read through these questions too quickly because, especially with gases, there are a lot of states that must be known in order for you to actually and successfully use one of the gas laws. For example, the number of molecules of gas has to be constant. To use Boyle's law, temperature has to be constant. And so we can get those clues by reading the question carefully. So at constant pressure. Pressure is not going to change. Pressure has to stay the same. Of a given quantity of gas. That means we're not adding any more molecules of gas and we're not taking away any molecules of gas. And so the number of molecules of gas, which later we'll find out that is represented by a lowercase n, that quantity does not change. And so we're asking about the relationship between temperature and volume. And we know that as temperature increases, volume will also increase. Now, you might think, well, if we increase temperature, the pressure increases also, right? That's true under a different set of circumstances. In this question, we're assuming that pressure is constant. If there's a question that is asking about the relationship between temperature and pressure, in that question, they'll do something to let you know that volume is constant, right? And the pressure can go up or down, but the volume's not going to. And it's really, really important because if we increase the temperature, but both volume and pressure have the capacity to change, that could really make it hard on us. In fact, we need a completely new gas law in order to do that, which we don't have at the moment. So if the volume is the only thing that can change, because pressure can't, pressure has to stay exactly the same, as temperature increases, volume increases. And conversely, as temperature decreases, volume also decreases. B, how does this explain the danger of throwing an aerosol can into a fire? Now, please do not write that it could blow up. We all know that if you throw an aerosol can into a fire, it can blow up. That's the problem. This question, again, pay attention to what it's saying. Don't rush through this. There's no extra points for finishing first. How does this explain that, right? We're trying to explain why this is the way it is. And so we know that as the pressure of a gas inside the can increases, right, because you're throwing it into a fire, into a heat source, that volume that is inside the gas is going to want to increase, right? Because in A, we just established that as temperature increases, volume decreases. The volume of that gas may increase so much that the can may explode, right? If that canister cannot expand or cannot handle that constant pressure, then it's going to explode, right? And then we have bad things happen. And that's why we don't throw aerosol cans into fires.